Sometimes it's called an axiom. But most of the time you'll just see the word postulate. Don't need to prove it, just accept that it's true. So the segment addition postulate, if B is between A and C, then you can say that AB plus BC is equal to AC. So let's draw a picture of what that means. So I have a line. On that line, I have B between A and C. So here's my segment A and C. And I'm just going to put B somewhere. Basically, all this is saying...
Hi.
Last time?
Yeah. Thanks.
Okay, so all this is saying is AB, so this distance right here, AB, and this distance here, BC. If you add them together, you get the total distance. That's all it's really saying. So you might see it this way also. So also, if AB plus BC equals AC, so you might be given this, and then from that you have to say, then B is between A and C. So sometimes you'll just be given this, and then from that you have to understand that means that B is between A and C. And there's a lot of that kind of weird flip-flopping stuff in geometry. So that's the segment addition postulate, which is basically just common knowledge, common sense, right? So find CD. So we have to find this distance right here. Find CD. But you want to just say, okay, well that's 42 minus 17. Yes. But you're in geometry now, so we're going to use the postulate. Okay? So this is what you would do. Notice it's a segment. So you're going to use the postulate. So write the equation and then solve. So you know if it's a segment, the segment addition postulate holds true. Therefore, CD plus DE has to equal CE. Basically, it's like writing an algebra problem and then plugging in what you know. So you know, you don't know CD, but you know DE equals CE. And then you just subtract 17, and CD equals 25. So that's how you need to write that. Get used to writing it like that. Now you may say, how come, I'm wondering if anybody is thinking, why is there no little segment line above there? Did anybody wonder that? So they're just going to throw another little tiny curveball at you. When you're talking about the length of a geometric figure, you don't put the segment line over it. It's an equal. Okay? But if you're talking about like two figures being equal, then you will. We're going to talk about that on the other side. Right here, equal versus congruent. Yes?
Did you need to add like units in there?
If they didn't give it units, then no. Good question. Okay, no units were given, so no. All right, I'm going to show you a PowerPoint. All right, we're going to fill this table in. Equal versus congruent. So basically, you're talking about lengths, numbers. You use equal. Oh, sorry, that's not very good, is it? Let's see if I can get a better picture for you. So AB equals BC is referring, I'll draw a picture here, refers to the 5. So if you have AB and it's 5, That's referring to the 5. This is a 5 right here. You use congruent when you're referring just to the geometric size and shape of figures. To geometric objects that have the same size and shape. So you would say segment AB is congruent to segment BC, same size and shape. So for congruent segments, this is just means you just show congruence. Have you seen this symbol before? That's congruence. It's an equal sign with a squiggly on top. You show congruence by using this instead of equal. So congruence is with the squiggly. You're saying that triangle is congruent to that triangle. Okay, graph the points in the chord and plane. Are segment XY and segment WZ congruent? So we have to draw them first and then determine if they're the same size and shape. So plot your points, -2, 1, 2, 3, 4, 5, -2, 3. So we're deciding whether segment XY is congruent to WZ. So yeah, we still have to count them to see if they are the same size and shape. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Yes, they are the same size and they're the same shape, so I can say that they're congruent. We're not referring to the actual number. Yes, segment XY is congruent to segment WZ. Same size and shape. That looks more like a tent. Whatever. It's a squiggly. We're not going to use a compass today. We're going to do another day where we learn how to do all these things on a compass. So let's just create one segment. Congruent to segment AB and call it CD. So that's why I had you get a ruler. How would you do that? You have to measure and then draw it over again and name it, and then you can state the fact that they are the same size and shape by using congruence. Use millimeters or inches, whichever is more accurate for you to use. It doesn't matter. Let me show you what you have to do.